Alright, this video is to help you with your corrections on our quiz from lessons 6.1 to 6.7. They're all about scientific notation and the rules of exponents. So we're going to be simplifying expressions with exponents and talking about scientific notation. So if you follow along with me here, and if there's any thing that you get stuck on, you can rewind and watch it as many times as you want. But the first one, everything's worth 2 points. For number 1, we have 5 to the negative second. Well, anytime we have a negative exponent, we can make it a positive exponent by moving it down to the bottom. So this is the same thing as 1 over 5 to the second. And 5 to the second is 25. So this is 1 over 25. Number 2, again, we have a negative exponent, so we want to move it to the bottom. We could write it as 1 over negative 3 to the positive second. That makes the exponent a positive 1. We still have a negative 3 in the parentheses. But when we take negative 3 squared, that's negative 3 times negative 3, which is a positive 9. So this is 1 over 9. That was worth 2 points. Got a lot more going on in number 3. The first step would be to get rid of any of the negative exponents, and we have several of them. So 4 to the negative second, we can write that as 4 to the positive second on the bottom. X to the negative third, we can write it as x to the positive third on the bottom. W to the 0 is just 1. So we could put a 1 up on top. And then y to the negative fifth, that's already on the bottom. So to make it y to the positive fifth, we're going to move it to the top. And so our final answer is 1 times y to the fifth, which we could write as just y to the fifth, over, and then 4 squared is 16, x to the third. So it's y to the fifth over 16x to the third. Moving on, it says for 4 and 5, convert the following numbers into scientific notation. 28 million, if we write it as in standard form, would just be 28 with 6 zeros after it. That's 28 million, which means in scientific notation we'd write 2.8. We'd put the decimal between the 2 and the 8, multiply it times 10 to the 1, 2, 3, 4, 5, 6, 7th power. So it's 2.8 times 10 to the 7th. Number 5, 3,500 thousandths. Well, part of us may have gotten messed up on the thousandths part. If the decimal is here, this is the tenths, hundredths, thousandths, 10 thousandths, 100 thousandths place, which means the 35 has to end in this spot, which means we're going to have 3 zeros. This decimal here is read 3,500 thousandths. In scientific notation, though, we would write it as 3.5 times 10 to the negative 1, 2, 3, 4th power. So it would look something like that. 6 through 11 are still dealing with scientific notation, but instead of just simply writing a number in scientific notation, we're multiplying or dividing numbers that are in scientific notation. So if we take a look at number 6, all of this is multiplication. 8 times 3 times 10 to the 6th. We can do 8 times 3. 8 times 3 is 24 times 10 to the 6th. Now, that's a correct answer, but it's just not written in scientific notation. Right now the decimal is here, and they're saying move it 6 spaces to the right. We want to put the decimal between the 2 and the 4 and write it as 2.4, but then it's going to have to be not times 10 to the 6th, but by times 10 to the 7th, because it would be 1 plus the 6 more spaces to get it to where we want it to be. So it's 2.4 times 10 to the 7th. Same thing with number 7. If we multiply 6 times 4.5, well, 6 times 4 is 24. 6 times 0.5, that's half of 6, which is 3. So that's going to be 27 times 10 to the negative 5th. Well, the decimal here is after the 7, 5 spaces to the left would put it here, but we want to write it in scientific notation, which means we want to put the decimal between the 2 and the 7. So instead of 5 spaces to the left, we only need to move it 4 spaces to the left, and it would be 2.7 times 10 to the negative 4th. Moving on to number 8. Again, we have 4 things. Here we have 4 things that we're multiplying together. I can multiply the 3.2 times the 4. The 3.2 times the 4 is 12.8. And then when I multiply 10 to the 4th times 10 to the 5th, those are like bases, And remember, when we have like bases, we just simply add the exponents. 4 plus 5 is to the 9th power. But this is not in scientific notation. We would take the decimal and move it 9 spaces to the right, but what we want to do is write it in scientific notation, which is going to be 1.28. The decimal always has to be after the first digit, and then 0.28, but then we're not going to make it times 10 to the 9th. We're going to have to put it times 10 to the 10th because we moved it one more space over. So that's number 8. Number 9, same idea as number 8. We're going to take 6.1 times 3. 6.1 times 3 is 18.3. But this time when we add the exponents, a negative 4 and a negative 2 is negative 6. So this means to take this decimal and move it 6 spaces to the left. But if we put the decimal where we want it, which is between the 1 and the 8, well then we'd only need to move it 5 spaces to the left. So it's going to be times 10 to the negative 5th. If we go on and look at number 10, here we're dividing. And we can divide the parts together. We can take the 8.6 divided by 2. 8.6 divided by 2 is 4.2. 4.3, sorry, 4.3. And then 10 to the 11th divided by 10 to the 5th. Here we're going to subtract the exponents because we're dividing like bases. And 11 minus 5 is 6. And this is already in scientific notation. It's just 4.3 times 10 to the 6th power. If we move on and look at number 11, same idea as in number 10, only 6.3 divided by 3 is 2.1. So we're going to have 2.1 times 10, and then we're going to take the 6 minus the negative 3. 6 minus a negative 3 is the same thing as 6 plus a positive 3, which is to the 9th power. And that is in scientific notation. So number 11 is 2.1 times 10 to the 9th. Remember, when you're making your corrections on the entire quiz, you not only have to put down what the correct answer is, but you also have to write down what it was that you messed up on. And it's important to figure that out so that you don't make that same mistake when it comes time to take our test. If we look at the back of our quiz, the back side of our quiz is not dealing with scientific notation anymore. It's dealing with those rules of exponents that we've been going over in class for a while. So if we take a look at number 12, we're going to start by multiplying the numbers that we can multiply together. Like, for example, 3 times 5, we know that that is 15. But then we can also take n to the 4th times n to the 6th. When we multiply things that have like bases, we simply add the exponents. So that's n to the 10th. And then we have m to the negative 6th and m to the 2nd. When we multiply those together, we add those exponents. That's going to be m to the negative 4th power. But then we have to remember that anytime we have a negative exponent, it goes to the bottom. So the 15 will stay on top. N to the 10th will stay in the top, in the numerator. But then m to the 4th, we'll write that in the denominator. And we'll have 15 n to the 10th over m to the 4th. Looking at number 13. Here we're taking an entire product to an exponent. So we're going to start by distributing that exponent. We're going to take 5 squared. 5 squared is 5 times 5, which is 25. Then we have x to the 3rd squared. Well, when we take a power to a power, we multiply the exponents, which means that's going to be x to the 6th. And then we have y to the 1st to the 2nd, which is just y to the 2nd. That's what we should have for number 13. And again, all these are worth 2 points on our quiz. Move on to number 14. A little bit more going on here in number 14, because we're going to first take this entire quantity to the 2nd power. So I'm going to take x to the 2nd to the 2nd. So just like we did in number 13, we're going to multiply those exponents because I'm taking a power to a power. That's x to the 4th. Then I'm going to take y to the negative 4th to the 2nd. When I multiply those together, I get y to the negative 8th power. I'm going to do the same thing with this set of parentheses. I'm going to take everything in it to the 3rd power, including the 2. 2 to the 3rd power means 2 times 2 times 2, which is 8. X to the negative 2nd to the 3rd power. Again, I'm taking a power to a power, so I multiply. That's x to the negative 6th And then y to the third. Again, when I multiply, I'm going to have y to the 9th. But I can do more here. I can simplify this more. I can't do anything with the 8, so that's going to stay an 8. But I can take x to the 4th times x to the negative 2nd. Well, when I add those exponents together, because they're like bases, I can, when I add them together, I'm going to get x to the negative 2nd. I'm going to put that on the bottom because it's a negative exponent. And then when I take y to the negative 8th times y to the 9th, that's y to the first power. It's a positive, so it'll stay on top, and it's just going to be 8y over x squared for number 14. We move on to number 15. I'm going to simplify this fraction. So the first thing I'm going to simplify is the 14 over 4. 14 and 4 are both even numbers. I can divide them both by 2. If I divide both those numbers by 2, I'm going to get 7 over 2. So 14 over 4 simply simplifies to 7 over 2. But then when I take n to the 6th over n to the 2nd, here we're dividing like bases, so I'm going to subtract the exponents. 6 minus 2 is 4, so I'm going to have n to the 4th. And that's on top because it is a positive exponent. That's different here with the m's, because when I take m to the 3rd over m to the 7th, I'm going to subtract those exponents just like I did here, but I get a negative 4. And instead of having m to the negative 4th on top, I'm going to move it to the bottom and write it as m to the positive 4th. So my final answer is just 7n to the 4th over 2m to the 4th. All right, let's move on to number 16. Number 16, I'm going to take this entire quantity, this entire quotient here, and square it, which means I can do several things here. I could simplify the x to the 3rd over the x to the 4th first, but I think what most people did on the quiz, and probably what I would do, is just take everything and square it, including the 3. 3 squared is 9. X to the 3rd squared is x to the 6th, because I'm taking a power to a power, so I multiply. And then on the bottom I have x to the 4th squared, which is x to the 8th. But then I can simplify this further, because the 9 I can't do anything with. That's going to stay on top. But when I take x to the 6th over x to the 8, I subtract those exponents. 6 minus 8 gives me negative 2. And because it's a negative exponent, I'm going to put it on the bottom as x to the 2nd. And then if we look at number 17, same idea here. We're just involving more of those rules of exponents. I'm going to start by taking this entire quotient to the 3rd power. 3 to the 3rd power means 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. Then when I take n to the 5th to the 3rd, I'm raising that power to a power, so I'm going to multiply, and that's n to the 15th. Then we have m to the negative 2nd to the 3rd. Well, when I raise negative 2nd to the 3rd power, again I'm multiplying, so that's going to be m to the negative 6th power. And then in the denominator, on the bottom, I'm going to take n to the 3rd. Again, when I take a power to a power, I multiply the exponents, so that's n to the 9th. And now this simplifies. I can't do anything with the 27, that stays 27. But then look at the n's. I have n to the 15th over n to the 9th. I'm dividing like bases, so I subtract the exponents. 15 minus 9 is 6. And it's a positive 6, so it stays on top. But the m to the negative 6, it's a negative exponent. So how do I make the negative exponent a positive one? I put it on the bottom as m to the positive 6. So the answer for number 17 is 27n to the 6th over m to the 6th. And again, make sure that when you make your corrections on this quiz, that you not only include the correct answers, but also write down what it was that you messed up the first time.